Let's talk about air bubbles in compasses and why they appear. And I'll also show you a method of repairing a compass with a bubble. Some compass manufacturers, not all, but some, claim that it's due to altitude changes or temperature shifts. And for a long time, we've been told that bubbles in a compass are normal. And sadly, that's actually now true because of poor manufacturing processes. Here's the reality. If a bubble forms when you hike up a hill or you use your compass in the winter, it's not caused by the altitude or the temperature or the air pressure, regardless of how many websites tell you that it is. A bubble is an effect, it's not the cause, and you do have to differentiate between the cause and the effect. The real cause of a bubble forming inside a compass is simply due to some manufacturers cost cutting without maintaining standards, and in other cases a complete lack of quality control. It does appear to me that some manufacturers assume that their customers will believe any explanation they care to give. After all, who is going to argue about a compass with the company that actually makes them? I will. Before we start, I'm sure you'll have read on lots of websites written by experts who will say that a bubble will not affect the operation of a compass. Don't you just love experts? Anyway, okay, with a small bubble, you can still use the compass in an emergency, but of course it will affect the way the compass operates. To say anything other than that is just absurd. For all compass manufacturers, I will guarantee one thing. Somebody within that company, whether it's in their compass design department or somewhere along the supply chain, they will understand the Navier-Stokes equations and Stokes' law and even Newton's law of viscosity. The problem is that we have as customers is that we can never talk to that person. All we get is an email from customer services saying that bubbles are normal. But if we could talk to somebody in that company who actually fully understands how their compass works, they would tell us that in a fluid-filled compass, if there's a bubble, this reduces the liquid volume inside the dial, which directly affects the shear forces acting on the needle. And since the damping force depends on the fluid's viscosity and pressure distribution, any reduction in the volume will change the needle's behavior. Oh, this isn't just my opinion, by the way. This is a really basic and fundamental principle of fluid dynamics. But let's not get bitter. Let's just stick to the facts. As we're talking about facts, here's the first one. There are only two ways that air can get into your compass. Either it was there when it left the factory, or it got in afterwards. Can anybody think of a third way? Fortunately, there's a really simple test to determine how the air got into your compass. So here I've got two compasses with bubbles in them. I'll bring the camera around so you can have a closer look. We gently squeeze the dial for a couple of seconds and then release it. If the bubble gets bigger, that means the compass has been damaged, and this has allowed fluid to escape, and this is replaced by air. In rare cases, there could be minute imperfections in the plastic or faulty sealing, and this could also allow air to seep in over time. But as this would probably affect an entire production batch, this would make it's quite unlikely that that's the cause. Most of the time, if the bubble grows, the compass has been damaged. In my case, that is almost always the case. I break so many compasses. I drop them, sit on them, I stand on them, or I just lose them. You know, so if there's a bubble in one of my compasses, most of it, virtually always, it's my fault. But when you squeeze the dial, if the bubble stays the same time after you release the dial, this means that the air was in the compass when it left the factory. So what can be done in either case? If the compass is damaged, the obvious answer is to be more careful. with your compass. Go and get another one and look after it this time. If the air was there from the start, the solution depends on two factors: where you live and how old the compass is. If you live in the UK, where we have very strong consumer protection laws, you can simply return it and get a new one or get a refund. If you live outside of the UK, I honestly don't know what your consumer rights are. This particular compass has a small bubble that when you squeeze it, it stays the same. It doesn't get bigger or smaller. So the air was in this compass when it left the factory. And when I say that, I don't mean that there was a visible bubble when you bought it. Instead, I'm talking about dissolved gases in the fluid. Any liquid exposed to air will absorb some fluid over time. In a well-run factory with good manufacturing processes and good quality control, the filling of the dial, the compass dial, with the fluid, this will be done inside a vacuum chamber, and this will remove virtually all dissolved gases. Afterwards, the compass would also undergo thermal conditioning and would be tested at different temperatures and pressures just to ensure that no gas remains in the fluid. Unfortunately, when manufacturers skip these steps or do them poorly, the fluid retains dissolved gases. Later, when it experiences altitude changes or temperature fluctuations, those gases, they come out of the solution and they form a bubble, which is why no reputable compass manufacturer should ever blame environmental factors for air bubbles. If the fluid was properly degassed and the compass was sealed correctly, bubbles simply won't appear. Again, unless the compass is damaged. So if you have a compass with a bubble inside it, you have two choices. You can replace it, which is the simplest solution, and it's the one that I would recommend, or you can try and repair it. Today we're going to try and repair these two compasses. It wouldn't be much of a video if I didn't. We'll refill the dial and then we'll seal the hole. If the compass is damaged, the first step is to actually find out where the air is actually coming in. And the way to do that is squeeze the dial, and then eventually you'll be able to, and I'll show you, I'll hold it up. So hopefully you can actually see the air coming into that at the side. There it is. Can you hopefully see that? So we now know that the air is coming in at the base of the second orienting line to the right hand side of the orienting arrow. So we now know where that is. If the compass isn't damaged, like this one here, we still need to get the air out. So what we'll do is we'll drill a hole in the compass, and all you need is one of these. Hold the compass steady. Only joking. Sorry, I couldn't resist. We are going to have to make a hole in it, but not with that. So a question could be, why drain the fluid out? Why not just let the air come out and then seal the hole? The simple answer is I don't know what's inside this dial at the moment, what type of fluid is in there. And I can't be sure that it will mix perfectly with the new fluid that I'm going to put in. I'll be refilling the compass with this isopropyl alcohol. I buy this on Amazon. It's £4.50 a litre. It costs nothing. Make sure that when you buy it, it's 99.99%. Otherwise, it won't work. So there are some things that you'll need. But the easiest solution, as I said earlier on, if your compass has a bubble in it, throw it away and get a new one. But if you want to try and repair it, this is what you'll need. The first thing you'll need is, you won't need a big drill like that. You'll need, well, this is what I use. If you've got one of these, I use these, which is hopefully you can see that. That's a 0.8mm drill bit. And I use that in just a standard Dremel. You'll need a way to seal the hole once you've drilled it, or once you finish your repairs. I use this. This is just a clear epoxy, but there are other options. You can get lots of things that will seal holes in plastic. You'll need a way to smooth off the epoxy afterwards, because it never goes on flat. I use this, which is just a sanding pad. It's a 180 grit sanding pad. It's really simple, and as I said, you'll need some fluid to actually put into the dial. In this case, as I said, it's just isopropyl alcohol. If you don't have these exact bits, you can substitute them with anything that will do the job. However, there is one piece of equipment that you absolutely must have. You must have protective gloves. And I'll say that again. You must have protective gloves. So simply, just please don't do this without wearing gloves. There's a very good reason for that. Is because I don't know what chemical is inside this dial. If it's from a major manufacturer, Sunto, Silver, Brunton, Kamenga, Breithaupt, you know that it's going to be okay. But it's supposed to be some sort of inert isopar or alcohol-based oil. But we all know there are some manufacturers in some parts of the world who will use very strange chemicals in cheap copies of compasses. And they could burn your skin, or they might not, but you don't know. So please wear gloves. I won't say anything more on that other than it's not worth getting skin burns just to save a few pounds on a new compass. The aim is to replace the fluid, or what's left of it, in this compass with this isopropyl alcohol. And there is a problem with doing this straight away, because in this alcohol there is already air and gases dissolved in it. And if we use it as it is, we put it into our compass, after the repair we'll be back to where we were when we started. Bubbles will start to form in the compass. So we need to remove as much of the air and gases from this liquid as we possibly can. There are a number of ways to degas fluids, and the best method would have been in the factory to use a vacuum chamber, but let's not go back to that. There are also lots of DIY methods. None of them are as effective as a vacuum chamber, but they will do the job. I've seen people using bicycle pumps with reversed valves. You know, there's lots of ways to do it. Many of the ways involve heating isopropyl alcohol in a pan on a stove. I don't want to say anything rude. I just don't. I'm not going to call them idiots. Let's just say that is ill-advised. This stuff here, isopropyl alcohol, has a flash point of 12 degrees C, which is about 53 degrees Fahrenheit. That's about the same temperature as the cold water comes out of your tap in the kitchen. A flash point is the temperature at which a liquid will produce a flammable gas. So if you heat this up on your stove in a pan, as soon as it gets to 12 degrees, which don't forget is the same temperature as normal cold water, it will start to produce a flammable gas. Your house could literally explode with you inside it and the rest of your family. I really have seen people doing this on videos, and it's... I know YouTube's about entertainment, but no, I'm not going to say anymore. Do not heat this stuff on a stove in a pan. Simple as that. The way I'm going to do it is I am going to heat it, but I'm going to heat it with hot water. And I'm going to boil the kettle well away from this. And I'm going to keep this sealed. The actual fluid itself won't cause you any harm. It's the gases that come off the top. They are... let's not go there. Just don't do it. So I'm going to heat this with hot water. And so the first thing I need to do is boil the kettle. So bear with me, I'll put the kettle on, but I'll put this outside first, just so it's well, the kettle isn't going to produce a spark. But, you know, that's enough said. I'm going to go and put this outside. So the first thing we're going to do is we need to get a bowl of warm water. And the way to do that at the right temperature, we're looking for around 50 centigrade. What's that? About 120 Fahrenheit. So all we're going to do is, I'm going to use this small bowl. So I'll put in 1.5 bowls of boiling water, and then the same amount of cold water, and that'll, boiling to cold, that'll give us approximately 50 C, which is what we're looking for. It's like a cooking show. There's a cookery show on the TV. I'll show you how to bake a cake. I would that would be also ill-advised to watch me making a cake. Anyway, so there we have our bath of approximately, it's not that hot, it's warm. I'm going to go outside now and get the alcohol and bring it back in. So the top is still tightly closed. All I'm going to do is I'm going to put that into its warm bath and leave it now. Just let it sit there for around 10 minutes just to heat it up. Every now and again, every few minutes, take it out. It hasn't been in long enough now, but it's for demonstration purposes. And just swirl it around slightly and then put it back. Don't shake it vigorously, because that will make the gases actually be reabsorbed into the liquid, which is the opposite of what we want. We want it to release. But every now and again, just take it out, give it a gentle swirl, and then place it back. So I'll come back in 10 minutes time. It's been sat in its bath now for a good 10 minutes. So all I'm going to do now, this is the easiest bit, is take it out and leave it on the side. Just leave it sat like this. Just leave it for a good 30 minutes until it cools down to room temperature. Don't be tempted to try and rush these stages. You know, it does take at least 10 minutes in the hot bath, and then it does take at least half an hour for it to cool back down again. And what each of these stages does is it allows the gases to come out of the surface of the liquid, and this cooling process also does that. So don't be tempted to say, well, it's been in 15 minutes, that'll be fine. Half an hour is half an hour. So it's been sat there for half an hour. Now, you remember what I said about everything's about timing. This is also about timing. It's not minutes, this is in seconds. What we're going, at the moment, what we've got is, we've got a build-up of pressure in the top, in the space above the liquid in the container. We need to release that pressure. Otherwise, any air and gases that are in this upper space, they'll be absorbed back into the liquid, which is the opposite of what we want to happen. So I'm going to unscrew the top, but I'm not going to take it all the way off. All I want to do is I want to completely undo it and then immediately tighten it back up again. I just want the pressure to go out of the top. So I'm looking for around the top to be unscrewed for around 1 second. No longer. Here we go. So that was it. All I did, unscrew it and then screwed it back on. So now that liquid is as degassed as we can get it at home. There are other DIY methods, but unless you have the right equipment and you're trained to use it, they're not good. For this YouTube video, this is the safest method of doing it. So now we have our fluid ready. The next thing to do is to empty the compass dial. And if the compass is damaged and it has a hole in it, you can just repeatedly squeeze the dial until all the liquid comes out. If the hole is around the edge of the dial, you're going to have to disassemble the compass. And you need to be really, really careful with this, because most compasses aren't designed to come apart. And so disassembling them can be quite difficult. And don't forget, sooner or later you're going to have to reassemble it, so be very, very careful. As an example, these Silver Expedition 4s, well, you can see the there's actually not much, there's about half empty, that thing. They have a small brass ring that goes around the inside edge, and they're not easy to get out, and you have to be really careful when taking them out. Hang on. It's half it out. Hang on. Use this. And the trick is with these is not to try and prise out the brass ring, but rather move the dial away from the edge so the brass ring just lifts out. Don't pull the brass ring because you'll deform it and you'll never ever get it back in again. That's the trick. Push the dial away from the edge. So when it comes out, it still wants to be in the regular pentagon shape. It has to be like that. If it's not in that shape, you will never reassemble it. And if this is deformed, the best thing to do is just throw the whole thing away, because it will never go back together again. I've taken a lot of these compasses to pieces. So we'll keep that very safely. We'll put it over there so it doesn't get damaged. And then all we do, there's the inside, take off the white section. And if you remember, I said that the hole was to the right of the orienting arrow. So what we'll do is we'll put a mark on this just so we know what we're doing. So that's that. And then we will just simply repeatedly squeeze the dial until it's completely empty. Here we go. Let's have a look. Hopefully it's in the right place. Oh yes, here we are. I'll bring it across. So if you squeeze the dial, so it's like this, you can actually see the oil coming out of the inside of the dial. So what we'll do is I'll just carry on doing that until the dial is completely empty. I'll speed this bit up because it can take a while. Yeah, that's it. Get a cloth. Right, so that dial is now, I would say, so this is now completely empty, this dial. So what we need to do now, I think it's going to be quite difficult to get anything to go through that hole safely. So what I think we'll do is we'll drill, I can see the small hole, but we'll drill a larger hole just to make it easier to, if I can get my Dremel. Let's have a look. What are we going to do? Just make sure it's working. So we can see where the black dot is there, so we know where the hole is. I can actually see the hole. The glasses, by the way, are just because this is such a thin, you know, it's less than a millimeter thing, and if it snaps, it'll be moving at some horrendous rate. So I always, the trick is with these, by the way, is don't do that. Do it as slowly as you can. You don't want to crack it. Right, there's the hole. All I'm going to do is slowly drill a hole, and that's it. That's all it takes. Just do it really, really slowly. I was going to hold it up to the camera, but it's so small. It's less than, just over 0.5 millimeter big. You won't be able to see it. So that's that. If we were doing it in a compass like this that isn't damaged, then I'd probably, I wouldn't disassemble the compass. What I'd probably do is drill through the base. You know, just the less taking apart and putting back together again with the compass you do, the better it is. But as the hole was on the edge on this one, we had no choice. So the next thing to do is we need to refill this compass with this fluid. Let me just get this out. And all we do exactly the opposite of what we just did. We pour this quite slow. Don't do it up here and let it all splash in, because you just put in air into the fluid. So just do it as slowly as you possibly can. Just you don't need the whole thing, you know, just enough. So if we was to use this again now, we'd have to degas it again. And there's the small black dot at the bottom, so I know where the hole is. I can see the hole. All I'm going to do is completely submerge this into the alcohol and then squeeze it. I'm not sure how to show you this. Hopefully you can see it on there. Let me hold it up. So the bubbles are actually, I'll hold it up like this, put it to the edge. The bubbles of air are actually, every time I squeeze, air is coming out of the container, out of the dial. And I'll keep doing this until the dial is completely full and there's no air in the inside of the dial. I'll come back to you. Right, so what's happened here is now when I squeeze it, no air comes out of it. So now this is completely full. More importantly, an easier way to test. If you notice, the dial is actually sat on the bottom of the glass bowl. If it floats, it means there's air in it. If it doesn't float, there is no air in it. So now I know that it's completely full. So all we need to do now is seal that hole and then reassemble the compass. So let's have a go at sealing the hole. There are lots of products that you can actually use to fill the hole at the top of the dial that we've just made. But whichever you choose, make sure that it can be applied on a wet surface. I use standard clear epoxy, which is this stuff here. And I also use these toothpicks. The reason I use clear epoxy, by the way, is it seems to work for me. Even though on the package it actually says don't use it on a wet surface, it's always worked for me, so that's why I work it. This is actually made by the same people who make Gorilla Glue. If you live in the UK, you can get this from B&Q, clear epoxy. It's got 2 sections on it, but just 1 plunger. So when you actually dispense it, the same amount of each chemical comes out. So it takes all that's one of the reasons I use it. It takes the guesswork out of it. All you do is just invert it and allow the bubbles, I don't know if you can see this, allow the bubbles to rise away from the base before you actually start depressing the plunger. Here we go, that'll do. And I'm going to, just for this video, I'm going to dispense way too much. You need only a tiny amount. As you can see, both sections come out. Don't get this on your clothes, by the way. It will never come out. I know from bitter experience. And then, using a toothpick, just mix it. Just mix the 2 chemicals for around sort of 10-15 seconds, or it will start to look grey or white when you're mixing it. But don't worry about that. It actually does dry perfectly clear. So once it's done this, and then the reason we're going to use a toothpick is to fill the hole. You want a really tiny amount. Don't get a big lump on it, because eventually you're going to have to smooth it off, and the more you put on, the longer it's going to take to smooth it off. So it's now mixed. So just using a toothpick, I can see where the hole is there. I'm going to actually push the toothpick under the water, so that at no time can any air get into that hole. And then we're going to simply cover the hole, and that is now perfectly sealed. We can take it out. The trick is turn it so that the epoxy isn't facing downward. So it's, you don't want the epoxy at the top, because some of it may run into the dial. And let's just give it a wipe. Don't wipe off the epoxy, obviously. You need to leave this now for around 30 seconds just to let the epoxy set off, or cure, and then after that you can just leave it. So as you can see now, that has, where's it gone? I don't know if you can see that. That's actually worked. There is no air inside this compass, so it has inside the dial, so it has worked. And I'm guessing that's about 30 seconds. So all we're going to do now is nothing. We're going to literally leave that where it is and do nothing. Well, I might put it up there just so I don't spill it, but you now have to leave it for 24 hours. Don't be tempted to Especially if you're a guy. It's a guy thing. I do it. We all do it. You know, every now and again, give it a little prod just to see if it's working. It is working. Just leave it for a full 24 hours. Once that's done, it's a matter of using your grit paper, or I've got this 180 grit block. All you're going to do tomorrow, this time tomorrow, once it's hard, just slowly sand it off so it smooths the edges, and then reassemble the compass, give it a test, and off you go. If you drill a hole in the base of this, remember when you're smoothing it off, there are orienting lines on the base of this compass, so you don't want to rub too hard. Just make sure that you do it, you know, lightly. Don't actually rub any of the compass markings off. Once again, seal the hole, give it a test, and then off you go up into the hills. That's it, really. Hopefully you found this interesting. I have fixed quite a few compasses like this, but I've seen some people giving out some strange advice, so I thought this is how I do it. If you've got your own way of doing it that works for you, that's fine, but this is how I do it. Anyway, thanks for watching.